Hello, chemistry students. Today we're going to learn about matter. So matter is anything that has mass and takes up space or has volume. And we classify matter into 4 specific pieces. And when we classify them, we ask ourselves questions first to do that. And the first question you should ask yourself is, can it be physically separated? Not chemically, but physically. An example of a physical separation would be filtration or evaporation. So if I have salt water, I can evaporate the water and get the salt. So I can separate my salt from my water. And if it can be physically separated, then it is a mixture. If it cannot be physically separated through filtration or evaporation, then it is a pure substance. An example of that would be water. You can't separate water into smaller forms physically by filtering or evaporation. Next thing, let's go back over our mixture. To our mixture, is the composition uniform throughout? Our mixtures we can separate into 2 other forms. And we ask ourselves the question, is the composition uniform throughout, or does it look the same throughout? Like for instance, let's go back to salt water and water. If I put a glass of salt water next to a glass of water and I asked you to just by looking at it, to just look at it, if you'd be able to tell me what the difference is, you probably wouldn't be able to. Now if I asked you could taste it, then you would be able to. But just by looking at it, if they look the same and the composition is uniform, which means it all looks like the same thing, then it is called a homogeneous mixture or a homogeneous. If you can tell the difference between the individual pieces, or it doesn't look like it's all the same thing all throughout, then it is a heterogeneous mixture. If you look at these pictures here, we've got a clear liquid and then we've got kind of a foggy liquid, and there's a light going through both of them. And if you notice, if you cannot see the light beam in the clear substance, that means it is homogeneous. It's very uniform throughout. This other solution right here that you can see the light going through, if you can see the little particles floating around, it is not uniform. You can actually see little pieces in there. So that is a heterogeneous mixture. Now let's go back to our pure substance. Our pure substance can also be broken down into 2 other pieces. And we ask ourselves the question, is it made up of only one type of atom on the periodic table? Now we were talking about water, which has the chemical formula of H2O. And is it made up of only one type of atom on the periodic table? The answer to that is no, because it's made up of hydrogen and oxygen, so it would be a compound. If it is made up of only one type of atom on the periodic table, it is called an element. Now let's talk about pure substances. Pure substances are uniform, unchanging composition. Every sample has exactly the same characteristic properties and composition, and it either exists as compounds or elements. So in our pure substances, we have 2 types. We have an element. An example of this would be silver. It is found on the periodic table. It cannot be separated into simpler substances by physical or chemical means. It takes a nuclear reaction to break them apart. So in order to break a silver atom into smaller pieces, we have to break the nucleus apart. Compounds. This is baking soda, NaHCO3. That 3 should be a lowercase down there. Compounds are combinations of 2 or more elements, and they are chemically bonded together. A chemical change is required to combine these elements or to separate the compounds back into elements. Mixtures. 2 or more pure substances, which could be a compound or an element, which have been combined such that each substance retains its own chemical identity. An example would be flour and sugar. You can separate flour from sugar by using a filter. Flour is much finer than sugar, so the flour would go through the filter and the sugar could stay on top of the filter, and each one would still taste like, the flour would still taste like flour and the sugar would still taste like sugar. There are 2 types of mixtures. Heterogeneous mixture, an example of this would be dirt. It is not uniform throughout, which means you can see the different particles in there, and they're usually made of very large molecules. A homogeneous mixture, an example would be sodas. If you look through a soda, it all looks the same. You can't pick out the individual dye molecules or the individual sugar molecules and the individual water molecules. So they're uniform. They are also called solutions, and they're made of very small molecules. In a homogeneous mixture, examples of them would be a gas-liquid homogeneous mixture is a soda, which is carbon dioxide and water. A gas-gas homogeneous mixture is an example would be air, which is composed of nitrogen, oxygen, argon, water vapor, and some other things. A liquid-liquid homogeneous mixture would be gasoline, rubbing alcohol, or vinegar. And a solid-solid homogeneous mixture we call alloys, and those are mixtures of metals like brass or steel or 14-karat gold. 14-karat gold is made of silver and gold. All right, now let's do some examples. We have soda. So the first question we're going to ask ourselves, can it be physically separated? We need to find out if it's a pure substance or a mixture. Soda, can it be physically separated by evaporation or filtration? Well, I know I can separate my water from my sugar just by evaporation, so that would be a mixture. And now we have to find out, is it a homogeneous mixture or a heterogeneous mixture? So we have to see, if we look at it, does it all look the same, or can we pick out the individual pieces? And it all looks the same, so it would be a homogeneous mixture. Rust. Rust, is it a pure substance or a mixture? We have to ask ourselves, can it be physically separated by filtration or evaporation? Well, you have to know that rust is oxidized metal, and it cannot be separated by filtration or evaporation, so it is a pure substance. And then we have to ask ourselves, is it an element or a compound? Well, if you look on the periodic table, you will not find an element called rust. So what is a compound? Iced tea. Can it be physically separated? Well, iced tea has ice and tea, and the tea has sugar and water. So we know that it's a mixture because it has more than one substance in it, pure substance. And since I can pick out the ice from the tea, we know that it's heterogeneous. Chicken soup. Well, we know it's composed of at least water and chicken and probably carrots and onions. So that would be a mixture because all of those are separate compounds, and we can physically separate it with our fingers. So then we have to ask ourselves, is it homogeneous or heterogeneous? Does chicken soup look the same all throughout? And the answer to that would be no, because I can see the chicken from the onions. Dirt. Well, we already talked about that. Dirt is a mixture because it can be physically separated. You can pick out the individual pieces, and it is a heterogeneous mixture. Chlorine is a pure substance. I know that because it is an element. If you look it up on the periodic table, it's the letter Cl. Sugar. Sugar has a compound formula of C6H12O6. Knowing that, it cannot be physically separated by filtration or evaporation, so it is a pure substance. And then we have to ask ourselves, element or compound? Well, it would have to be a compound because it has more than one element in its formula. Gasoline, we actually saw that on the previous slide. That is a mixture of different hydrocarbons, and it can be physically separated. I actually used to do that where I worked at Fina Oil and Chemical. But when you look at gasoline, does it all look the same? Or can you pick out the individual pieces? Well, it all looks the same. And then lastly, water. We have to ask ourselves, mixture or pure substance? Can it be physically separated? Water cannot be physically separated by filtration or evaporation. If you evaporate it, there's nothing left. The water's just gone or evaporated off. So it is a pure substance. Water has a chemical formula of H2O, which means it has more than one element. It is hydrogen and oxygen chemically bound together, which makes it a compound. Thanks for watching.